Hello and welcome to Sleepy Science Story. This is your time to slow down, to let the world soften at the edges, and to drift somewhere quieter for a while. Tonight, we're going to float through the velvet dark of space to visit something small, strange, and almost shy, a visitor that came from beyond our solar system, gliding silently through the cold. Three-Eye Atlas. It's not as famous as Oumuamua or Borisov, but it carries its own quiet mystery, a handful of atoms, a story made of dust and distance. I do hope this video isn't so interesting it keeps you awake. But if it does, at least your dreams will be filled with starlight and cosmic crumbs. Before we begin our dreamy science wandering, I'd love to know, where in the world are you listening from tonight? Let me know in the comments. It always feels wonderful to imagine these soft space stories being whispered to sleepy minds across oceans and time zones. If you find peace here, a gentle like and a soft tap on subscribe would mean the world. Thank you, truly, for being part of this cozy constellation. Let's begin our journey gently, the way all space stories should begin, slowly, with a deep breath and a drifting thought. When astronomers first noticed Three-Eye Atlas, it was already fading. Imagine looking out into the night sky and spotting a glimmer that isn't supposed to be there, a point of light that does not follow the familiar dance of our planets or comets. It appeared one evening, then another, its position shifting in a way that felt just slightly off. There was a rhythm missing, as though the music of the solar system had suddenly gained a foreign note. They traced its path carefully, comparing it against known orbits, only to find that this one was different. It wasn't circling our sun in a loop. It was sweeping past in a long, graceful curve, the kind that never closes. That was when the realization came, quiet but thrilling. Three-Eye Atlas was not one of ours. It had come from somewhere else, somewhere beyond the faintest edge of the sun's influence. By the time we saw it, it had already completed most of its story. Its beginning lay in a star system far away, maybe one that has already changed beyond recognition. What we were seeing was the end of a journey that might have lasted millions, perhaps billions, of years. Picture it drifting through the deep black between stars, moving in silence through distances so vast they erase the very idea of movement. There are no winds there. No pressure, no sound. Only gravity, slow and constant, bending paths like invisible threads. Three-Eye Atlas would have passed other stars, their light faint pinpricks that never grew closer. Maybe it brushed through the frozen outskirts of alien solar systems, gathering a thin frost of new material. Or maybe it traveled untouched, a small relic of another creation. By the time it reached our neighborhood, it had become something delicate and ghostly, part ice, part dust. A bundle of molecules carrying the fingerprints of its home. When the sunlight began to warm its surface, the ice started to whisper away into vapor. Tiny particles of dust followed, forming a soft veil that caught sunlight like silk. For a brief time, it shimmered. For a few weeks, our telescopes could trace its glow, faint but certain, against the velvet backdrop of space. Then, as quietly as it had appeared, it began to fade. What makes Three-Eye Atlas so strangely beautiful is its lack of belonging. It had no parent planet, no familiar orbit, no destination. It was a traveler between stars, passing through our skies for a moment, then gone forever. It never meant to visit us, and yet, for a short time, we became part of its story. Its light fell into our telescopes, its dust into our data, and in that brief meeting, we learned something about the vastness of the universe and the smallness of our place within it. It's easy to imagine it now, far from the warmth of the sun, gliding back into darkness. The trail it left has dispersed, its pieces scattered among the cosmic winds. Perhaps another civilization, far away, will one day see a faint streak of light and wonder where it came from, the same way we did. Maybe they'll give it a name, and for a moment, they too will feel the same quiet awe. There is something comforting in that thought. The idea that even in the infinite silence of space, stories still drift. They are written not in ink or sound, but in motion and dust and light. 3. Atlas had no past we could trace and no future we can follow. Yet in passing, it offered us the gentlest reminder that even brief visitors can leave lasting wonder behind. Now, as we let our thoughts drift like that lonely traveler, we can almost feel its slow glide beyond the reach of our sight, a whisper fading into the deep, and somewhere out there, among the stars, it continues on, quiet and infinite. It is strange to think that our entire solar system, with all its planets, moons, and endless spinning motion, can occasionally receive visitors from beyond its own borders. For most of human history, we thought of the sky as a closed story, every comet and asteroid belonging somehow to our own sun's family. Yet when 3i Atlas appeared, it quietly joined an exceedingly rare group, one so small that we can count its members on the fingers of one sleepy hand. It became the third interstellar object ever known, following in the mysterious trails of Oumuamua and Borisov, two earlier guests who had also come wandering from distant suns. Each of these travelers carried its own quiet kind of magic. Oumuamua was the first, discovered in 2017, shaped oddly like a tumbling shard of rock, thin and elongated, reflecting sunlight in ways that made astronomers question whether it was even natural. Some imagined it as a piece of an ancient planet, some as an artificial fragment, though no one could ever say for sure. 2 years later, Borisov arrived, looking more familiar, a true comet with a shining tail of gas and ice, behaving exactly as comets should. And then, in 2019, came 3i Atlas, a faint blue wanderer that seemed at first to promise another spectacular cometary display. For a moment, telescopes around the world turned toward it, eager to greet this new arrival from the galactic sea. The naming might sound technical, but there's a quiet poetry to it. The 3i means it is the third interstellar object ever found, and Atlas comes from the telescope system that first spotted it. The name fits it perfectly, for like the Titan who carried the heavens, this tiny object carried the weight of another world's history on its icy shoulders. It drifted through our sky not as a stranger, but as a storyteller, speaking in particles of dust and frozen molecules. What makes interstellar objects like 3i Atlas so precious is the impossibility of their journeys. To travel from one star to another requires crossing vast stretches of emptiness, where light itself takes years to move from point to point. Most comets and asteroids are forever tied to their stars, looping around them in endless cycles. For one to escape, something extraordinary must happen. a close encounter with a massive planet, or a violent collision that flings it outward fast enough to break free from its star's gravity. Once set loose, it becomes a drifter, slipping through the galaxy in eternal solitude. That was the life of 3i Atlas, wandering in darkness for perhaps millions of years before it finally entered our sight. When astronomers realized it was on a hyperbolic orbit, meaning it would never return, they must have felt both wonder and sadness. To witness something so old and so far traveled, only to know it would vanish again, is like seeing a shooting star that burns for centuries but is visible for only seconds. The data they gathered during its brief visit would have to suffice. The only clues we may ever have about its composition, its structure, and the distant world it once called home. In that sense, each interstellar visitor is not just a comet or a rock. It is a cosmic envoy, carrying secrets of places we cannot yet reach. It tells us that the galaxy is not a lonely place, that stars exchange material, that dust and ice can wander between systems, and that perhaps even the seeds of life might travel across those endless distances. 3i Atlas is one more voice in that quiet chorus, a reminder that the universe is not made of isolated islands, but of bridges too faint for most eyes to see. Now that it has passed beyond the light of our telescopes, we can only imagine it continuing on its endless voyage, following Borisov and Oumuamua into the soft infinity beyond. The thought of them, 3 faint travelers moving through the dark and distant paths, feels oddly comforting. They are like drifting thoughts of the cosmos itself, moving between dreams. Each one leaves behind a trace of mystery, a whisper of how much we have yet to learn. So when we think of 3i Atlas as the third interstellar object, it is not just a number. It is a position in a growing story, a new chapter in the gentle realization that our solar system is open to the stars, that we too exist in a galaxy full of movement and meeting. For now, 3i Atlas is gone, its faint blue glow extinguished, but the memory of its passing lingers like the aftertaste of starlight. It reminds us that the universe is alive with travelers, and that even the smallest among them can leave a mark across the vast dark sea of space. The dust that built 3i Atlas is older than the sun itself, and perhaps older than our planet could ever dream of being. When you think about that, it becomes hard to imagine time in the same way we normally do. These grains were once part of a great molecular cloud, a gentle ocean of gas and microscopic debris stretching for light years. Within that cloud, hydrogen atoms gathered and clung to one another, and bits of carbon, oxygen, and silicon danced quietly in the cold. Every now and then, gravity would take a deeper breath, pulling some of that drifting material closer until it began to swirl and thicken, whispering the earliest promise of a star. Somewhere within such a place, far away from our sun's birthplace, 3i Atlas took shape. If you could hold one of those tiny particles that make up its body, you would be holding something that has traveled through epochs longer than life on Earth. Imagine dust so ancient it has seen stars live and die, has drifted through the ashes of supernovae, has soaked up light from constellations that no longer exist. In that small grain lies the memory of entire worlds, the fragments of countless beginnings and endings. Every bit of it carries a kind of cosmic DNA, a record written in elements and isotopes rather than letters and words. To study that dust, if we ever could, would be to read a story older than our sun, older than our understanding of time itself. The atoms within 3I Atlas were not made all at once. Some were forged in the hearts of massive stars, pressed together under unimaginable heat and pressure, then scattered across the galaxy when those stars died in brilliant bursts. Others condensed more gently in cooler regions, joining together in molecular clouds that drifted for millions of years. Over time, those atoms joined to form ice, rock, and organic molecules. They bound themselves to one another, not knowing that one day they would be flung from their home and sent on a journey through the dark. When scientists say that the dust of 3I Atlas is older than our sun, what they really mean is that it is a piece of galactic history. Before our solar system began to swirl into being, this material was already old, already shaped by the cycle of stellar birth and death. The sun and planets are made from similar ingredients, but they were reassembled from a newer batch, the cosmic equivalent of a fresh mix. 3I Atlas, though, never joined that process. It remained part of an older story, a witness to eras before our corner of the galaxy had even begun to glow. There is something humbling in knowing that this dust traveled so far and lasted so long. It reminds us that permanence is not always a matter of strength but of patience. These grains survived the destruction of stars, the cold of deep space, and the violence of being ejected from one solar system only to pass near another. And yet they persisted, unbroken, unchanged in their essence. When sunlight touched them again for the first time in perhaps millions of years, they responded softly, glowing faintly, as if waking from a dream. To think of dust as ancient as 3I Atlas is to see how connected everything truly is. The atoms that make up our bodies, our air, our oceans, all once drifted in similar clouds. We are made of the same kind of matter, rearranged and reborn. Somewhere in that realization lies a quiet comfort. Nothing truly disappears in the cosmos. It only changes form, changes story. 3I Atlas may be gone now, its fragile structure undone by sunlight and heat, but its dust continues to wander. It might one day become part of another star, another world, another sky. So as we lie here thinking of it, floating in our own gentle orbit around the sun, it's peaceful to imagine that some small part of 3I Atlas, some ancient grain of cosmic memory, is still gliding through the dark, carrying with it the light of forgotten stars and the quiet reminder that we are all made of dust that once belonged elsewhere. When astronomers first noticed that 3I Atlas was starting to fall apart, there was a sense of quiet wonder more than alarm. Most comets brighten as they approach the sun, the heat awakening their icy surfaces and turning them into luminous travelers trailing long tails of gas and dust. 3I Atlas seemed to follow that pattern at first. It brightened as though it were preparing to put on a show. Telescopes caught its shimmering arc against the dark, the faint blue-green glow of volatile gases beginning to escape from its surface. But then something unexpected happened. Its brightness changed too quickly, and the shape of its coma, the fuzzy shell of vapor that surrounds a comet, began to stretch and thin. It was not growing livelier, it was unraveling. For a time, astronomers hoped it might still survive its passage around the Sunday. They adjusted their telescopes, calculating trajectories, estimating how much mass it could lose before becoming unstable. But 3i Atlas was fragile in a way they had not anticipated. The sun's warmth, gentle from our distance, was too much for the soft body of this interstellar traveler. Instead of bursting or colliding, it simply began to separate, the way frost melts from a leaf in early morning. Piece by piece, its structure gave way, and the comet that had traveled for millions of years began to dissolve into a trail of drifting fragments. It was not an explosion but a surrender. In photographs taken from powerful observatories, its once bright nucleus elongated into a pale smear. Each section that broke off reflected sunlight a little differently, some shining faintly, some fading almost at once. Within weeks, what had been a singular visitor became a line of scattered dust. Scientists could trace the pieces like beads along an invisible thread, each moving slightly apart, each destined to vanish into the background. The world had waited to study this object from beyond the stars, and instead of a stable body to analyze, they were left with a disappearing trace. Yet there was beauty in that fading. Watching 3i Atlas break apart was like watching the last snow of winter drift into spring air. Nothing violent, only soft and inevitable. It reminded those who studied it that not everything in space endures. Sometimes the most ancient things are the most delicate, and sometimes their final act is simply to scatter what they have carried for ages. Each grain released from its core carried with it a memory of distant creation, a particle of another star system set free into ours. Even as the comet fell to pieces, astronomers could still detect the gases that once held it together. Water vapor, carbon monoxide, traces of cyanide compounds, all whispering stories of chemistry older than Earth. The spectrum of light from its dissolving coma spoke in colors too faint for our eyes but clear enough for instruments to record. It was like listening to a voice from another world fading into static, every word precious because you knew it would soon be gone. For many, this gentle disintegration gave 3i Atlas a kind of quiet dignity. It did not die in a blaze of light or collide spectacularly. It simply gave itself back to the universe, its material drifting into new orbits, its essence becoming part of the same cosmic dust from which it had once been born. Somewhere, perhaps far from where we can see, those fragments continue to travel, slowly dimming, their paths shaped by sunlight and gravity, crossing through the invisible borders of our solar system until they are lost to the night once more. To think of it that way makes its end feel less like destruction and more like continuation. The particles that made up 3i Atlas will not vanish. They will spread, join new dust clouds, mix with material from our own system, and one day perhaps become part of a future comet. Its passing through our sky was brief, but its story is long. In its quiet explosion, there was the reminder that endings in the universe are never absolute. They are transformations, soft changes of form, like vapor rising from melting frost. And so 3i Atlas left us not with a spectacle of survival, but with something more human, more tender, a lesson in fragility, in how even across the emptiness of space, everything that begins must eventually yield to light, to heat, and to time. As we imagine those fragments still gliding somewhere out there, faint and free, it feels almost like a kind of peace. At the heart of 3i Atlas, There was never anything fierce or indestructible. It was fragile in a way that made it almost poetic, a body held together by the gentlest forces the cosmos could offer. Where asteroids are solid and metallic, comets like 3I Atlas are more like frozen sponges, made of porous ice and dust loosely bound by gravity and the faint attraction of their own particles. If you could have held a piece of it in your hand, which, of course, would be impossible, you might have crushed it between your fingers. It would have been soft in texture, glittering faintly, like a snowball made from powdered glass. The warmth of your palm would have sent it hissing into vapor, leaving behind nothing but a shimmer of frost and memory. Scientists believe the core of 3I Atlas was composed of the same ingredients found in many comets: water ice, carbon dioxide, carbon monoxide, and silicate dust. But its particular blend, shaped under alien skies, made it more delicate than most. It was likely riddled with tiny cavities, pockets of gas trapped over millions of years that began to escape as it neared our Sunday. That slow release of pressure may have started small cracks spreading through its body. The cracks grew quietly, like the soft snapping of distant ice on a frozen lake. And then, when sunlight touched it more directly, the whole structure began to yield. The idea of fragility in space is strangely comforting. We often think of the cosmos as vast and harsh, full of collisions and gravity and unrelenting forces. Yet here was a traveler so delicate that a little warmth could undo it. It carried within it a balance between strength and impermanence, just enough cohesion to survive for millions of years, just enough weakness to fall apart in a few short weeks. When we look at such an object through a telescope, it seems still and perfect, but the truth is that it is always in motion, always changing, always vulnerable. The dust and ice within 3I Atlas may have been ancient, but the way they fit together was temporary. In a sense, it was like a dream solidified, something beautiful but not meant to last. Each flake of ice and speck of dust had its own origin story, formed in the swirling nursery of another star long ago. When those materials came together, they made something new for a while, a small frozen traveler, a momentary shape given to ancient matter. Its fragility was not a flaw but part of its nature. Things that travel through the deep cold of space often do so in pieces, and sometimes those pieces only find coherence for a moment before scattering again. As sunlight touched its surface, gases began to evaporate, releasing streams of vapor that pushed gently against its body. These outgassing jets are what create a comet's faint tail, the delicate arc of light that trails behind it. For 3I Atlas, those gentle jets might have been both its beauty and its undoing. Each little burst pushed against the fragile structure, loosening what gravity held together until, at last, the bonds broke and the comet began to dissolve. It wasn't an explosion of destruction, but a slow unfurling, a sigh in space. To think of 3I Atlas's fragile heart is to think about the paradox of endurance and decay. It survived unimaginable distances, the long dark between the stars, the silence of interstellar space. Yet when it arrived in our sky, when it finally reached the warmth of another sun, it could not endure that tenderness. The same light that made it visible to us also caused it to fall apart. There is a kind of poetry in that. Some things exist only long enough to be seen once, and in that briefness lies their meaning. Now, What remains of its heart is scattered dust, each particle gliding away from the sun into the dark once more. Somewhere, perhaps, a few fragments still shimmer faintly, tumbling end over end, reflecting the light of a star they will never see again. The rest has become part of the quiet mist of space, mingling with the same cosmic dust that forms new worlds. The fragile heart of 3i Atlas may be gone, but in breaking, it joined everything else, its pieces now part of the endless cycle of creation and loss that keeps the universe both alive and dreaming. When 3i Atlas began to warm under the light of our sun, it was almost like watching a fragile traveler awaken too quickly from a long sleep. For millions of years it had floated through the coldest regions of the galaxy, untouched and undisturbed, its fragile structure preserved by the perfect stillness of space. But the warmth that brings life to our world can also bring unraveling to others. As the comet drifted closer to the sun, that warmth seeped into its icy heart, and what followed was both beautiful and inevitable. Unlike Borisov, which blazed across the sky with confidence, 3i Atlas could not withstand the growing heat. Its ices began to vaporize, its crust began to crumble, and small jets of escaping gas pushed against it from within. Every breath of vapor that left its surface was a whisper of exhaustion, a release of pressure that had been building over ages. Those soft expulsions of gas created faint halos of light, giving it the appearance of glowing softly, but the light was a sign of unraveling, not endurance. The comet that had traveled for so long began to dissolve in front of us. For a while, it seemed to fight the inevitable. Telescopes captured images of its coma brightening, as though it were preparing to put on a grand display. The scientists who followed it must have hoped, if only quietly, that it might hold together long enough for more data to be gathered. They wanted to understand it, to measure its chemistry, to read its ancient story through the light it scattered. But comets are unpredictable, and this one was fragile to its core. The glow that seemed to promise a show was, in truth, a prelude to its breaking. When it finally began to separate, it did so gently. There was no explosion, no violent fragmentation. It simply came undone, its pieces drifting apart like feathers released into a slow current. The process unfolded across days and weeks, almost imperceptibly. One day the core appeared bright and whole, and the next, slightly elongated, slightly less defined. Observers could trace the transformation as though watching a snowflake melt. In its softness, it showed us the quiet side of cosmic destruction, one that felt strangely peaceful. It was not that the comet failed in its journey. It simply reached the limit of what it could endure. The heat that melted its ice and scattered its dust was the same energy that had allowed it to exist at all. Without stars, there are no comets, no light to illuminate them, no warmth to shape their paths. In that sense, 3i Atlas did not fall apart in vain. It completed its purpose by showing us what happens when something ancient meets the breath of a new Sunday. Its decay was a conversation between cold and warmth, between darkness and light. When we look at it this way, its breaking becomes almost poetic. It reminds us that even in space, fragility has its place. Things do not always end in fire or collision. Sometimes they end in soft unraveling, in slow transformation. And though 3i Atlas could not survive the sun's embrace, it gave us something even rarer than endurance. It gave us a glimpse of vulnerability across cosmic time, a moment where something that had survived the emptiness of space succumbed gracefully to light. As the final fragments drifted away, they formed a long, faint ribbon across the sky. That ribbon was the last visible trace of the comet's existence, glimmering softly before fading into the black. Somewhere within that stream of particles, a few grains may still travel together, bound by nothing more than shared direction. They are, in their way, still part of the same traveler. Perhaps, as centuries pass, those particles will drift beyond the pull of our sun and return to the interstellar dark, ready to continue their endless wandering. In the end, 3i Atlas was the comet that could not cope, and yet it gave us one of the gentlest endings ever recorded in the sky. It did not rage against the light. It simply yielded, its ancient dust becoming part of our solar wind, its memory joining the great silent story of things that pass through, shimmer for a moment, and disappear. And in that quiet surrender, there was something deeply human, something that mirrored our own fragility under the same sun that lights us all. Every fragment of 3i Atlas carried within it a quiet echo of another star. When scientists studied its motion, they realized that its path through the galaxy was not shaped by our sun but by something much farther away, some long-forgotten gravitational push from a system beyond our reach. Each speck of dust, each frozen molecule that made up the body of this comet, had once belonged to a place that is no longer the same. Perhaps it was born in the outskirts of a distant planetary system, near the frozen borders where light fades and ice gathers. Maybe it once circled a warm young star before being flung into the void by the pull of a passing planet. Whatever its story, every atom it carried was a souvenir from a sun we will never see. It is humbling to imagine that the carbon in its dust may have condensed in the atmosphere of an alien star. The oxygen in its ice may have formed in a nebula that collapsed long before ours, and the nitrogen locked inside its frozen layers could have come from the cool chemistry of a planet that no longer exists. It is as if the comet were a message in a bottle, sent across the vast ocean of space and time, carrying within it traces of a civilization older than stars. When we caught sight of it, we were not just observing an object, we were glimpsing a memory from another corner of the galaxy. The beauty of 3i Atlas was not only in its appearance but in what it represented. For so long, we have looked at the night sky and thought of our solar system as a kind of island. The planets, the moons, the asteroids, all bound together under one sun, sharing its warmth and its gravity. But 3i Atlas reminded us that the universe is not made of islands. It is an open sea, and sometimes the tides of gravity send visitors drifting from one shore to another. The space between stars is not empty but filled with travelers, tiny, ancient, patient travelers moving slowly through the dark. When astronomers traced its motion backward, the path led not to any known system but into the depths of the Milky Way. Its speed was too high, its direction too free. It had come from nowhere we could name and would soon return to nowhere we could follow. Yet for a brief time, as it passed near our sun, its light mingled with ours. The same photons that once touched the ice of another world now found their way into our telescopes, into our eyes. In that brief meeting, two star systems that had never known each other shared a single moment of connection. If we think of the galaxy as a great web, with each star connected by invisible threads of motion, then 3I Atlas was a strand of that web brushing against ours. It carried chemistry that could teach us how matter behaves in the far reaches of space, how organic compounds form in the cold, and how the ingredients for life might wander freely between stars. Perhaps, long ago, something like 3I Atlas drifted into our own solar system when Earth was still young, seeding our world with the molecules that would one day awaken into life. The same process might be happening now, somewhere far away, as the dust of this comet finds its way to a new home. It is comforting to think that the universe recycles its materials so tenderly, that what was once part of one world might one day become part of another, that the ice of 3I Atlas could melt into the rain of some future planet, or its dust could settle onto the soil of a world not yet born. In that way, nothing is truly lost. The story simply continues in different forms, passing silently through the dark like a whisper shared between distant suns. When we look up at the stars tonight, we might remember that somewhere out there, far beyond our sight, the remnants of 3I Atlas are still traveling, carrying with them the echo of a star that once burned brightly in a place we will never see. It is a reminder that we, too, are made of borrowed starlight, drifting for a time before we return to the great cosmic sea. When people first hear the name 3I Atlas, they often imagine a mythic figure, a cosmic giant holding the sky upon his shoulders. It feels fitting, doesn't it? The name evokes strength and endurance, as though this little comet were carrying an entire universe on its back. But the truth is more modest, more human. The name comes from the telescope system that discovered it, the Asteroid Terrestrial Impact Last Alert System, a network of observatories quietly watching the heavens for anything that might wander too close to Earth. Still, it is a beautiful coincidence that this instrument should lend its name to something that really does seem to bear the weight of other worlds. The Atlas telescopes are not grand domes perched in lonely mountains like the old observatories of legend. They are small, vigilant machines scattered across Hawaii, South Africa, and Chile, designed to scan the whole sky every night. Their purpose is to protect us, to give warning of asteroids that might one day pass too near. But in watching for danger, they also find wonder. The sky is full of unexpected visitors, and sometimes, instead of spotting a threat, ATLAS finds something that stirs the imagination. That is what happened in April of 2020, when a faint moving light appeared in its field of view. The astronomers who noticed it might have felt that familiar pulse of curiosity, the quiet excitement of finding something new. At first, they likely assumed it was a comet within our own solar system. But when they traced its orbit, the numbers began to look strange. It was moving too fast, coming from too far, its path curved in a way that no returning comet could manage. It was as if it had wandered into our solar system from a road that led beyond all maps. The discovery was confirmed, and just like that, Atlas had found a second interstellar comet, a third visitor overall from beyond our sun's domain. It is comforting to think that even the instruments we build for caution can lead us toward wonder. The name Atlas may have been given in technical precision, but it carries something poetic now. This telescope, like its mythic namesake, holds up the sky each night, scanning it for hidden shapes and distant stories. And in its gaze, it caught a fragment of another world passing by. It feels almost as if the ancient myth had come full circle. The Titan who bore the heavens on his shoulders is reborn in a modern telescope, and from his labor comes a gift, a glimpse of a traveler from beyond. For a brief moment, 3i Atlas connected myth and science, past and future, legend and data. Its name became more than a label, it became part of its story. When astronomers whispered about it across radio frequencies and email threads, they were not only speaking of coordinates and magnitudes, they were speaking of a feeling, the quiet awe of seeing something small and transient against the infinite. In the silence of the night sky, the word Atlas carries a kind of poetry. It reminds us that science, at its heart, is not separate from myth-making. Both are ways of looking at the unknown and giving it meaning. When we name things, we give them a place in our story. This little interstellar comet, fragile and fading, was given a name that connects it to an ancient idea, the burden of the sky, the endurance of the cosmos, the patience of those who watch and wait. And though 3i Atlas no longer glows in our telescopes, the name remains, anchored in the data and in our imagination. Somewhere, perhaps, its fragments are still drifting through the dark, and if they could think or dream, maybe they would know their name, the one given to them by the eyes that saw them pass. In that way, the title Atlas feels perfectly chosen after all. Not because this comet bore the heavens, but because it carried a little of our curiosity, our longing to look up, and our endless wish to understand the stars. When the sunlight began to touch 3i Atlas, it woke a color that almost seemed too delicate to be real. Through telescopes, it appeared faintly blue, a pale, ghostly hue that shimmered around its icy body. It wasn't a bold or glowing blue like that of a summer sky, but the soft kind that hides inside shadows or glints at the edge of dawn. The color came from the gases released as the comet warmed, tiny molecules escaping from its surface, scattering sunlight in ways that our eyes could never see directly, but that instruments could capture and translate into that fragile glow. Among those gases was cyanogen, a molecule made of carbon and nitrogen that often gives comets their distinctive blue-green halos. To us, it looks beautiful, ethereal, almost painterly. But behind that beauty lies chemistry born from the oldest processes in the universe. Cyanogen forms when simple atoms, drifting in cold darkness, find each other and bond in the presence of ultraviolet light. In the vacuum of space, that process takes patience measured not in minutes or days, but in millennia. Each of those molecules within 3i Atlas may have been resting in its icy home for millions of years before a brief moment of sunlight freed it. As the ice began to sublimate, turning directly from solid to gas, those particles escaped in clouds that surrounded the comet. They created a soft glow that seemed to breathe, expanding outward until it formed a hazy envelope of light around the nucleus. From a distance, that glow looked smooth and still, but up close, if you could somehow drift near it without harm, you would see a faint storm of motion, each molecule spinning away, colliding, scattering, shining. The blue light we saw from Earth was not the comet itself, but the light of the sun transformed by chemistry, a conversation between energy and matter taking place across millions of kilometers. It is strange to think that such a small and fragile thing can make the darkness around it seem alive. In a universe filled with violence and vastness, 3i Atlas glowed softly, quietly, as though it wanted to exist without disturbing the silence. Its faint blue haze was like a sigh in space, beautiful but temporary. Every moment it brightened was also a moment it lost mass, each flicker of light a sign of its gradual undoing. And yet, that is what made it all the more mesmerizing. The comet's glow was not a show of strength, but of surrender. It shone because it was disappearing. Astronomers studying the color of 3i Atlas knew what it meant scientifically, but perhaps they also felt something beyond analysis, a kind of wonder that numbers cannot hold. They knew the spectrum of its light, the wavelengths, the ratios of gas, but still, there is a part of seeing that kind of glow that feels personal. It reminds us that even in the farthest cold, beauty happens, that even an object made of rock and ice can create something that looks almost gentle. The faint blue of 3i Atlas was more than color. It was the visible trace of time itself. Every photon that scattered from its gases carried with it a memory of sunlight and shadow, a record of distance and warmth. To look at it through a telescope was to see something that had traveled not just through space, but through eras. It was light from an ancient traveler, reflected through chemistry that had been waiting longer than we can comprehend. In the quiet of a dark observatory, you can imagine an astronomer looking through the data, watching that pale blue glow flicker across a screen. Outside, the world is still, the night filled with its own kind of calm. Somewhere out there, 3i Atlas drifts on, its blue tail fading, its color dissolving into the dark. And though the glow is gone now, its light remains in the memories of those who saw it, in the images captured by careful lenses, and in the thought that even in the vast black sea of space, the universe sometimes paints in colors too soft to last. If you could have floated near 3i Atlas when it was still whole, drifting in the silence beyond Mars, you might have noticed something unexpected. The airless void would have smelled faintly sharp and metallic, though there is no air in space to carry a scent. The gases escaping from the comet's surface would have carried traces of hydrogen cyanide, ammonia, methanol, and sulfur compounds, chemicals that, if somehow concentrated in a sealed chamber, would tickle the senses in strange and unpleasant ways. It would be the scent of burnt almonds mixed with bitter ozone, the sort of smell that seems both clean and toxic, like the moment after lightning strikes. But these faint wisps, invisible and thin, would have been the breath of the comet itself, a perfume of ancient chemistry slowly unraveling under the sunday. When sunlight reaches a comet, the frozen molecules on its surface awaken. Water ice begins to turn directly into vapor, and as it does, it drags other gases along with it. Ammonia, methane, carbon monoxide, and hydrogen cyanide all rise together in a slow exhalation. These gases then interact with solar radiation, breaking apart into smaller pieces, glowing faintly as they scatter photons. To us, that glow appears as a soft halo around the comet. but within it lies an entire chemical ballet. Atoms collide and combine, molecules spin and separate. Energy trades places with matter in quiet exchanges that have been happening since before our sun was born. Scientists have studied the gases that escape from comets for decades because they tell a story about how worlds are made. Many of the same compounds found in comets exist in the raw material that forms planets. The presence of hydrogen cyanide and formaldehyde, for instance, is significant because those molecules can, under the right conditions, give rise to amino acids, the building blocks of life. It is humbling to think that the same icy chemistry responsible for the faint scent of a comet might also be responsible for the spark of biology itself. Perhaps, long ago, when our own solar system was young, comets not so different from 3I Atlas rained upon Earth, bringing those molecules to our oceans, where sunlight and time worked their slow magic. There is a strange comfort in imagining the universe filled with smells that no one can smell, with breezes that do not blow, and with chemistry that happens in silence. If space had a scent, it might be something like this, a faint trace of metal, stone, and burnt sweetness. The echo of creation spread too thin to breathe. 3I Atlas carried that scent as it drifted near our sun, releasing it molecule by molecule into the void. No one could ever experience it directly, yet the idea of it feels familiar, almost intimate. It reminds us that even in places where nothing seems alive, there are still invisible stories unfolding. The gases that made up the comet's faint aroma were fragile things, easily destroyed by sunlight. As they broke apart, they left behind tiny ions that danced in the solar wind, glowing briefly before being swept away. To the human eye, there was nothing to see, but in the data collected by telescopes, the patterns of those molecules became visible. Each line in a spectrum, each tiny shift in wavelength, was like a note in the comet's quiet song. The scent and the light were part of the same process, two forms of energy born from the same release. When astronomers talk about 3I Atlas, they often focus on its orbit, its disintegration, its significance as an interstellar visitor. But behind those facts lies something far more tender. It was a body that breathed, if only metaphorically. It released the gases trapped for ages within it, offering them back to the universe as a kind of farewell. Those molecules, once part of a distant star's nursery, became once again part of the galaxy's drifting air, waiting for the next chapter in their journey. And so, in a way, the comet's scent, though never smelled, lingers in the cosmos. The burnt sweetness of hydrogen cyanide, the metallic hint of ammonia, the earthy whisper of methanol, all of it now scattered and gone, yet still part of the endless chemistry that ties every star, every world, and every passing traveler together. It is one more reminder that even in the silence of space, nothing is ever truly still, and even what we cannot touch or smell has a story worth imagining. As 3I Atlas moved closer to the sun, something invisible began to happen. Its frozen gases started to vibrate, a dance so small that no human ear could ever hear it, and yet it produced its own kind of music. This was not music in the way we understand it, not waves of air carrying sound through space, but a symphony of light and energy. Each molecule that escaped from the comet's surface began to shimmer and oscillate under the touch of sunlight. Those vibrations emitted signals that our instruments could detect, translating their faint whispers into data. To astronomers, it was as if the comet were singing a song made of chemistry and motion, a song carried across the void. Comets are natural instruments of resonance. When they warm, the molecules trapped in their icy cores begin to stretch and twist. Water molecules rotate at certain frequencies, carbon monoxide at others, and methane and ammonia each have their own subtle rhythm. When these molecules interact with sunlight, they absorb certain wavelengths and release others, and those exchanges can be measured. The result is a spectral fingerprint, a pattern of lines that reveals exactly what the comet is made of. For 3I Atlas, that fingerprint told a story of both familiarity and distance. It contained the same ingredients as our own comets, but in slightly different proportions, shaped by a chemistry that belonged to another star's nursery. Imagine, for a moment, that you could hear this process. It would not be a loud or chaotic sound. It would be slow and soft, like wind moving through glass reeds. Each note would correspond to a molecule awakening under sunlight. Each harmonic a collision of particles drifting in a thin halo of vapor. If space could translate those vibrations into something our ears could perceive, the song of 3I Atlas might sound like the gentle hum of distant wind chimes, echoing through a cathedral made of darkness. When astronomers observed its light, they watched it pulse and flicker in subtle ways. Those flickers were not random. They were the visible reflection of gases escaping unevenly from the surface, creating slight changes in brightness as the comet rotated. These variations told them how quickly it was spinning, where the jets of vapor were strongest, and how the structure of the comet might have been shifting. The light was a code, and scientists, patient and careful, worked to decipher it, knowing that each shift of brightness brought them closer to understanding a world that would soon vanish forever. To study something like this is to listen without ears and to see without eyes. It requires faith in instruments, in numbers, and in the idea that beauty exists even when it cannot be directly experienced. 3I Atlas offered a perfect example of this. No one could touch it, no one could hear it, and yet its vibrations, its frequencies, told us everything we needed to know about its life. The universe is full of such unhearable music, the quiet frequencies of molecules, the hum of magnetic fields, the soft radiation of old stars cooling into darkness. It is a reminder that silence in space is not emptiness but fullness beyond our senses. As the comet continued its path, its song grew fainter. The molecules that once shimmered began to fade as they drifted away, carried off by the solar wind. The frequencies softened until they blended with the background hum of the galaxy itself. For a while, astronomers could still pick out the signals, faint but distinct, before they too vanished into the noise of the universe. Now, all that remains of the music of 3I Atlas are the records stored on servers and in data archives around the world. But if you close your eyes and let your imagination wander, you might still catch a sense of it. A soundless melody of light, a vibration traveling endlessly through the dark, a cosmic lullaby that once played just for us as the comet passed by. It is peaceful to think that somewhere in the vastness, those same vibrations continue, rippling through particles and photons, the eternal background song of creation itself. The slow unraveling of 3I Atlas was one of those quiet cosmic moments that held both sadness and serenity. When scientists watched the comet through their telescopes, they did not see a sudden flash or explosion. Instead, they saw a gradual fading, a soft loosening of structure, as if the universe were untying a knot made of ice and dust. Over days and weeks, the glow around the comet began to stretch and blur. Its once distinct nucleus, that solid point of light at its center, became fuzzy, then diffuse, and finally disappeared into the surrounding haze. What had been a single traveler became a drifting cloud. It was not destruction in the way we often imagine it. There was no violence, no final moment of collapse. It was more like watching snow melt in the first light of morning, the edges softening, the shape dissolving until only traces remained. For astronomers, the transformation was both beautiful and bittersweet. They had hoped to study the comet's structure in detail, to learn how an object from beyond our solar system behaves. Instead, they watched it vanish before their eyes, leaving behind only scattered dust and faint gas trails. But in that disappearance, there was something deeply poetic. It reminded us that even in space, the most ancient and enduring things are also the most fragile. Each photograph taken during those weeks told a slightly different story. One showed a bright streak against the stars, another revealed a thin ribbon of debris stretching across the black. When combined, these images traced the comet's slow disintegration, like a time-lapse of a life gently fading. Astronomers could measure the rate of that fading, calculate how much mass it lost, and estimate when the nucleus ceased to exist as a solid object. What they found was astonishingly gentle. It did not crumble all at once, but rather peeled away layer by layer, as heat and sunlight worked patiently through its porous body. It is easy to imagine that last moment, when the final fragment broke free, and the comet became nothing more than a drifting trail. In that moment, it might have looked like a ghost of itself, a pale shimmer against the dark, still reflecting sunlight but no longer whole. The fragments spread out, each following its own slightly different path, carried by momentum and by the solar wind. Together they formed a faint arc that lingered for a time, before dispersing completely. To watch something ancient dissolve so peacefully is a strange kind of comfort. It reminds us that endings in the universe are rarely sudden. They happen slowly, quietly, in patterns of transformation rather than erasure. The matter that once formed 3I Atlas still exists. It has simply changed form. Its dust is now part of the interplanetary medium, its atoms free to wander, perhaps to be caught one day by another gravitational field, another star's pull. The comet's disappearance was not an end but a continuation, its story spreading into countless new beginnings. Even so, the astronomers who had followed it must have felt a tinge of melancholy. There is something deeply human about watching something fade away after following it so closely. For a while, it had been part of our story, a name on our maps, a point of fascination that connected observers across continents. Then, quietly, it was gone. What remained was data, light curves, photographs, and a memory of the time when it shone. The slow unraveling of 3I Atlas serves as a gentle reminder of impermanence, not as a tragedy but as a truth of nature. Everything that forms must eventually transform. The comet's dissolution is the same process that once gave rise to stars and planets, the same cycle that shapes galaxies. Nothing in the cosmos truly vanishes. It only becomes part of something else. And so, even as the comet faded into invisibility, it left behind the soft assurance that its story was still unfolding, carried quietly by the very dust that once held it together. In the early weeks after its discovery, astronomers were filled with quiet excitement because 3I Atlas looked far brighter than expected. Through telescopes, it appeared as a soft, glowing bead in the darkness, its luminosity growing each night as it drew closer to the Sunday. Many thought this was the sign of a large, active comet, one that would become dazzling as it neared its closest point to us. For a short while, it seemed that we might witness one of the rarest sights of all, a bright interstellar comet visible even to the naked eye. But in the universe, light is not always what it seems. Brightness can be deceptive. It tells us how much sunlight an object reflects, but not how solid or how large it truly is. The glow of 3I Atlas came not only from its icy nucleus, but from the enormous cloud of dust and vapor that surrounded it. When the sun's light hit that expanding coma, it scattered in all directions, making the comet appear much larger and more luminous than it really was. It was a kind of illusion, a cosmic mirage created by the simplest interaction between light and matter. Scientists soon began to realize that something was off. The comet's brightness was increasing too rapidly. For it to shine that strongly, it would have needed to shed enormous amounts of material, far more than a stable body could manage. Observations from multiple observatories confirmed that its central nucleus was likely small, perhaps no larger than a few hundred meters across. What made it seem vast and impressive was the sheer volume of dust it was releasing as it broke apart. The light was not a sign of health but of decay. It was the comet's final performance, a burst of brilliance before fading away completely. There is something profoundly poetic about that. To shine brightest just before vanishing is a story as old as the stars. Supernovae do it, burning with one last flare before collapsing into darkness. Even ordinary sunsets remind us of it, glowing richest just before the light fades. 3I Atlas followed that same rhythm, a pattern that repeats everywhere in the cosmos, and perhaps even within us. The light that deceived our telescopes was not false, only misunderstood. It was not a lie but a fleeting truth, the visible expression of a process we had not yet recognized. When the data finally made sense, astronomers understood that they were watching a disintegration in progress. The light curve flattened, then dipped as the comet's brightness diminished. What had seemed like promise was actually the slow unraveling of structure. But in that fading glow, there was also revelation. The dust it shed gave scientists a chance to study the composition of material from another star system, something that would otherwise have remained locked away. The comet, in giving up its brightness, gave us its story. If you were to imagine watching it through a telescope, you might picture that faint smudge of blue-white light growing softer each night. You would not see the fragments separating, not directly, but you would sense it in the way the glow diffused, like a candle flame flickering out in slow motion. And as it faded, you might feel a small sense of loss, the way one does when a beautiful thing passes too soon. Yet there would also be peace in it, a quiet understanding that this was the natural end to a long journey. In its way, Three-Eye Atlas reminded us that the universe often hides truth in illusion. What looks bright may be fragile, what seems solid may already be dissolving, but even illusions have value. They draw our attention, they invite our wonder, and through them, we learn. The comet's deceptive brightness was not a trick, only a fleeting reflection of the delicate balance between light and loss. It shone for a while, it deceived, and then it disappeared, leaving behind only its memory, a pale echo of light that once drifted between the stars. Before it came apart, Three-Eye Atlas likely had a shape that was far from smooth or symmetrical. Unlike the tidy spheres of planets or the polished geometry of moons, comets are creatures of chaos. They are assembled from fragments of ice and dust, fused loosely in the cold, and sculpted slowly by sunlight and time. The shape of Three-Eye Atlas would have been irregular, perhaps stretched, perhaps lumpy, more like a piece of frozen bread dough than a perfect stone. Its surface would have been full of crevices, pits, and uneven ridges, every one of them a mark left by ancient chemistry and wandering. If one could have floated near it, there would be no sense of scale until a shadow passed along its edge. The sun's light would have struck it at an angle, revealing textures that told its history. Some regions might have been dark, coated in organic compounds that had formed from the slow reaction of carbon and nitrogen under ultraviolet light. Others might have glimmered faintly where ice was freshly exposed, reflecting just enough light to give it a dull sheen. Each hollow, each fractured edge, would have held clues about the conditions it once endured. A shape like that does not emerge by design but by survival. It is the result of collisions, heating, cooling, and endless drifting through the quiet sea of interstellar space. Comets like Three-Eye Atlas are shaped not only by what they are made of but by the paths they travel. For eons, it may have been frozen and untouched, its surface smooth from the calm of deep space. But when it entered our solar system, sunlight began to carve it anew. The ice within it expanded and contracted, cracking its crust. Small jets of vapor burst through, creating miniature eruptions that eroded its form. Even before it broke apart, its shape was already changing from moment to moment. The sun was sculpting it, gently but persistently, the way wind sculpts dunes or waves shape cliffs. Astronomers sometimes model comets as simple spheres for their calculations, but the reality is far more complex. The irregularities on the surface determine how a comet spins, how it vents gas, how its orbit shifts slightly over time. For Three-Eye Atlas, those irregularities might have made it wobble as it rotated, turning in uneven rhythms as jets of vapor pushed against it. In that motion, there was a kind of grace, like the slow roll of a drifting leaf. It was not perfect motion, but it was natural. That irregular spin may even have contributed to its disintegration, as stresses built along its fragile body until it could no longer hold together. There is something hauntingly beautiful about such imperfection. We often think of the cosmos as precise and orderly, but much of it is made of rough edges and asymmetry. The universe's artistry is unpolished. Its beauty lies in the rawness of its creations, in the way they reflect the forces that shape them. 3i Atlas was no exception. Its irregular body was a record of countless interactions, a physical memory of everything it had ever encountered. When it finally began to fall apart, that shape, the uneven, lumpy form that had carried it across the galaxy, dissolved into dust. Yet the memory of its structure lives on in the data, in the light it reflected, in the way its fragments spread across the sky. Each piece followed a path determined by its original position, its spin, its density. The comet may be gone, but the pattern of its disassembly still carries hints of what it once looked like. To imagine 3i Atlas as it was before the end is to imagine a sculpture carved by time rather than by hand, not graceful in the way of planets, but intimate in its irregularity, shaped by accidents and persistence. It was never meant to be permanent, and yet for millions of years, it held together long enough to travel between the stars and pass through our sun's light. That imperfect form, that lumpy, asymmetrical body, was a testament to endurance. It showed that even in the cold vastness of space, beauty does not need symmetry. It only needs to exist for a while, to drift, to carry the marks of where it has been, and to eventually return to dust. For most of its existence, 3i Atlas drifted through the dark between stars, where distances are so vast that time itself feels slow. Out there, in that space so empty it is almost beyond imagining, the comet moved silently, untouched by gravity strong enough to alter its course. The interstellar medium it passed through is not truly empty, though. It is a thin ocean of atoms and dust grains, spaced so far apart that a single particle might travel for miles before brushing against another. In that ocean, 3i Atlas glided, carrying with it the frozen memory of its birthplace. There is a kind of peace in that journey. Picture it moving endlessly forward, its surface cold and dark, its ices frozen solid since before our sun had even formed. It would have passed through regions where starlight was faint, only a scattered glow of distant suns illuminating its surface. At times, it might have crossed through the outskirts of nebulae, clouds of gas and light that shimmer faintly in the void. Those clouds, though vast, would have seemed delicate compared to the space surrounding them. Each time the comet drifted through such a region, its surface might have gathered a dusting of microscopic grains, new layers of history settling upon old. The motion of 3i Atlas was slow compared to the speed of light, but to us, it would still seem impossibly fast. Traveling perhaps tens of kilometers each second, it crossed between stars that are light years apart. The distances defy the imagination. Between one system and the next, there are stretches of emptiness so long that entire civilizations could rise and fall in the time it takes a comet to traverse them. And yet, through all of that, 3i Atlas endured. It neither burned nor froze to pieces. It remained intact, coasting through the quiet like a seed carried by an invisible wind. The silence of interstellar space is not like the silence of Earth. It is deeper, older, almost sacred. There are no echoes, no sound at all, only the faint hum of cosmic radiation and the pulse of particles drifting endlessly. If you could somehow stand upon the surface of 3i Atlas as it traveled, you would see nothing but darkness in every direction, punctuated by the cold light of stars. The sun would have been invisible, one more star among billions, and though you would hear nothing, you might feel the stillness as a kind of sound, a pressure of quiet so complete it becomes a presence. It may have passed by other travelers in that dark, other comets, asteroids, and fragments ejected from distant stars, each one moving silently, each one unaware of the others. Perhaps 3i Atlas brushed through faint trails of dust left behind by stars that had long since died, or through the magnetic fields that weave between systems like unseen threads. Every moment of that journey added to its story, etching invisible marks into its chemistry and form. When it finally approached our solar system, it was like a leaf drifting into a sunbeam after an eternity in shadow. The warmth awakened it, called it to life, and for the first time in millions of years, it began to change. But before that moment, for longer than we can truly comprehend, it had known only darkness, and in that darkness, it persisted. There is something almost meditative in thinking about that long voyage. A small, fragile object moving through infinite quiet, holding within it the remnants of another world. No destination, no purpose, just motion and endurance. It reminds us that even in the coldest and emptiest places, there is continuity. The universe does not forget what it has made. Every fragment of dust, every wandering comet, continues the story begun in the first moments of creation. 3i Atlas was one such fragment, carrying its story patiently through the dark, waiting for its brief encounter with the light before returning to the silence it had always known. Deep within the fragile body of 3i Atlas lay a secret library of chemistry, a cold archive of materials preserved since the earliest days of its birth. The heart of the comet was a place where temperatures had remained near absolute zero for countless ages, a stillness so complete that even atoms seemed reluctant to move. There, frozen into a delicate structure of ice and dust, were compounds that told the story of creation itself. Scientists believe that inside it, beneath its pale shell, were frozen gases such as carbon monoxide, methanol, ammonia, and water, mingled together like ingredients waiting for warmth to wake them. These simple substances are the alphabet of life, scattered throughout the cosmos wherever stars are born. They form in the densest parts of interstellar clouds, when dust grains gather and cool and atoms begin to cling to one another. Hydrogen bonds with oxygen to make water. Carbon links with nitrogen to form the fragile chains of organic molecules. And over time, the simplest forms of chemistry become capable of astonishing complexity. The comet's frozen heart was made from these same elements, locked away long before our sun began to shine. When sunlight began to reach it, the chemistry hidden inside 3i Atlas slowly came alive. Each layer of ice absorbed warmth, and molecules that had been motionless for millions of years began to stir. Water ice sublimated first, turning to vapor, followed by the release of more volatile gases like carbon monoxide and methane. These escaping vapors pushed outward through tiny cracks and vents, carrying with them dust and fragments of organic material. Every puff of gas was a miniature experiment, a reenactment of the processes that once shaped worlds. The mixture of compounds found in comets has always fascinated scientists because it mirrors the ingredients found in the clouds that give birth to stars and planets. To study 3I Atlas was to study a sample of another solar system's beginnings. Perhaps its parent star had planets once. Perhaps even oceans and atmospheres where similar chemistry took hold. The molecules it carried, carbon, hydrogen, oxygen, nitrogen, are the same ones found in every living thing on Earth. There is something comforting about that universality. The thought that the same simple patterns repeat themselves everywhere, that the spark of possibility exists even in the coldest corners of space. Some scientists believe that comets like 3I Atlas could be the messengers of life, carrying these compounds between stars. Over immense timescales, such objects wander from system to system, sometimes colliding with planets, delivering water and carbon and nitrogen like gifts from the cosmos. It is possible that life on Earth owes its existence to visitors, much like this one, long before humans had the words to wonder about it. In that sense, 3I Atlas was not just a relic but a participant in an ancient exchange between worlds. If we could have touched its interior, it would not have felt like rock. It would have been softer, more like compressed snow mixed with fine dust. The sunlight would have made it glisten faintly, but most of it would have remained hidden beneath the surface, waiting in the cold. Even as it disintegrated, the gases and particles it released joined the solar wind, dispersing into space, mingling with the same medium from which it had once been born. The cycle continued, quiet and eternal. To think of that fragile core, filled with frozen chemistry from a star we will never see, is to be reminded of the patient creativity of the universe. Nothing in it is wasted. Even a dying comet contributes to the vast circulation of matter, seeding new systems with the materials of life. In the cold heart of 3I Atlas, there was both an ending and a beginning, a whisper of how the universe renews itself, molecule by molecule, in the endless exchange between light and shadow, heat and cold, death and creation. When 3I Atlas finally broke apart, it did not vanish in an instant. Instead, its body gave itself up piece by piece, scattering fragments across the path it had followed through the sky. These pieces, though small, continued to glow faintly as sunlight touched their icy surfaces. For a while, it was as if the comet had multiplied itself, each fragment a tiny world of its own, drifting through space with a slow, dreamlike grace. Astronomers could still trace their faint shimmer through telescopes, following the path of what was once a single visitor now turned into a constellation of drifting remnants. Each fragment was like a page torn from a very old book, still legible, still carrying traces of the story it once belonged to. The dust and ice within them came from the same alien nursery, formed in the same cold cradle of another star. Even separated, those pieces were connected by their origin, fragments of a whole that had crossed unimaginable distances together. It is a comforting thought, in a way, that even after breaking, they remained companions for a time, gliding together through sunlight and silence. The breakup of 3I Atlas was not the end of its journey but a transformation. The fragments began to spread out slowly, their motion governed by the same laws that guide all things in space. Larger pieces continued along nearly the same trajectory, while smaller grains of dust drifted slightly away, pushed by the faint pressure of sunlight. From a distance, it might have looked like a faint smudge stretching across the stars, a ghost of motion left behind by something that no longer existed. Yet within that smudge was beauty, the quiet poetry of matter returning to the universe in a softer form. Astronomers studying the event could see how the light changed as the fragments spread apart. Each piece reflected the sun differently, some bright, some dim, depending on their composition and shape. Together, they created a flickering effect, like a candle's reflection trembling on water. To those watching, it was both a scientific observation and a moment of reflection on impermanence. Here was an object that had survived the dark for millions of years, now dissolving in the brief warmth of a star, leaving behind only dust and memory. Some of those fragments may still exist today, invisible to our telescopes, drifting outward in their slow arc away from the Sunday. Each is smaller than a mountain, perhaps no larger than a house, and they will continue to move along their paths for centuries before fading entirely into the background dust of the solar system. In time, they will pass beyond the reach of our instruments, into the same interstellar emptiness that once carried them here. There, they will rejoin the vast sea of particles that move between stars, becoming part of the material that forms future worlds. There is something deeply gentle about this ending. The comet did not crash or explode. It scattered itself like seeds, leaving a faint trail that will one day disperse completely. Its fragments will never return to the system that birthed them, but they will carry a piece of it with them forever. Each one is a reminder that even in breaking, something can continue. The comet's story did not stop when it fell apart. It simply changed its form, continuing to travel, continuing to share the starlight that had once warmed it. If you imagine those fragments now, far beyond where we can see, drifting slowly through the dark, you can almost picture them glowing faintly in the memory of sunlight. They are quiet travelers, each on its own path, each carrying the faint chemical fingerprints of a place we will never know. They are the remnants of something that was once whole, now turned into a gentle stream of dust moving endlessly toward the unknown. And perhaps, in their endless motion, they still tell the same story that the whole comet once told, a story of endurance, of motion, and of the beauty that exists even in the act of falling apart. When 3I Atlas entered our solar system, it did not come to stay. Its path through space was shaped by a geometry that allowed no return. The comet followed what astronomers call a hyperbolic orbit, a curve so open that it can never close upon itself. Everything born of our sun moves in circles or ellipses, held by the pull of gravity, but 3I Atlas was bound to no star. It came from the dark between suns and would return there once its brief crossing was complete. It passed near the sun only once, its path bending slightly as gravity tugged at it, then straightened again as it continued outward into the infinite. To imagine its journey is to imagine a visitor stepping softly through our world, leaving barely a footprint before fading into the mist. For a few short months, it shared our sky, glowing faintly in the lenses of telescopes, whispering its presence to those who were watching. Then, with quiet inevitability, it slipped away. Its orbit would never curve back toward us. The sun had changed its direction slightly, like a hand brushing past a drifting feather, but it could not keep it. The comet's speed and distance made that impossible. It was a traveler passing through, not a captive. The mathematics of such a path are simple in principle but profound in meaning. A hyperbolic orbit means freedom. It means that the object has more energy than the sun can contain, that even the immense gravity of a star cannot call it home. To reach such a state, 3I Atlas must have been given a tremendous push long ago, perhaps ejected from another solar system during the violent early days of planetary formation. A large planet may have flung it outward, the way Jupiter sometimes throws comets beyond the edge of our own system. That ejection set it on a course that would carry it through interstellar space for millions of years, drifting between the stars like a leaf in an endless tide. When it arrived here, its direction told astronomers everything. The angle of its approach, the speed at which it traveled, all confirmed that it was not from our sun's domain. The realization brought a quiet thrill, the same feeling one might have upon discovering a message in a bottle washed ashore from a distant land. To study something like that is to look beyond our own neighborhood, to touch something that has known other skies, other worlds, perhaps even other forms of light. For a brief time, we had the chance to observe it, to measure its light, to listen to its story written in data. And then, just as quietly as it had come, it was gone. Each day it moved farther from the sun, its fragments trailing behind, its brightness fading. Eventually, it slipped beyond the reach of even our most sensitive telescopes. But its orbit remains in our records, mapped in lines and numbers that trace its passage through our solar system. It will continue outward, moving ever slower as it climbs back into the galactic dark, until one day it passes so far from our sun that the light here becomes no more than a faint memory upon its surface. There is a kind of poetry in knowing that it will never return. It means that what we saw was unique, a moment that will never be repeated. The next time it passes near a star, it will not be ours. Perhaps another world, orbiting another sun, will glimpse it and give it a name of their own. They will see what we once saw, a faint, distant glow, a brief traveler from another system, and they will wonder, as we did, about the place it came from. Even now, long after it has left our view, its path still exists, invisible but certain. The ghost orbit of 3I Atlas stretches across the night, marking where it once was, where it turned, and where it vanished into the unknown. It is a reminder that the sky is not a fixed stage, but a living current of motion, filled with wanderers who come and go without pattern. 3I Atlas was one of those wanderers, passing through our sun's light only once, leaving behind no trace but the memory of a line through the stars, a path that begins nowhere and ends in forever. By the middle of 2020, the light of 3I Atlas had grown too faint to follow. The telescopes that had once traced its journey could no longer find it, even when they searched the exact coordinates where it should have been. Its once bright coma had vanished into the black, its fragments spread so thin that they no longer reflected enough sunlight to be seen. The comet that had drifted through our solar system with such quiet mystery was gone, absorbed into the endless background of space. There was no moment of farewell, no flash or sudden dimming that marked its disappearance. It simply faded, day by day, until the last trace of its light was swallowed by the dark. Astronomers kept watching for a while, just in case some remnant might pass through the field of their lenses, but none appeared. What was left of 3I Atlas had scattered too widely, the fragments drifting beyond the reach of any instrument. All that remained were the images, the data, and the knowledge that for a brief time we had glimpsed something from another star. There is something deeply human about the way we continue to look for what has already gone. The scientists who studied 3I Atlas knew it was beyond recovery, yet they searched the skies anyway, hoping for one last glimmer. Perhaps it was not only curiosity but affection, a desire to hold on to a visitor that had shared our part of the galaxy for such a short time. We are creatures who long for closure, even in science. And so, long after the comet had vanished, we still whispered about it, tracing its path in our minds, following its invisible orbit through the stars. The final data from its fading showed only faint hints of dust and gas, drifting in a line that stretched millions of kilometers across space. Those particles would continue to move outward, spreading thinner with every passing year, until even they became indistinguishable from the dust that already fills the void. In a sense, 3I Atlas did not disappear. It simply became part of everything else. Its atoms will travel forever, mixing with the same cosmic grains that once formed planets, stars, and other comets. The matter that once shimmered for us is still out there, carried on the breath of the universe. When we lose sight of an object like this, we are reminded of how vast and patient the cosmos is. Everything we can observe is temporary. Every light eventually fades. Yet, paradoxically, nothing truly ends. The comet's dust will drift for billions of years, perhaps to be caught one day in the gravity of another system, to fall into the orbit of another star. There, it might become part of a new comet, or even the soil of a young planet. The cycle will continue quietly, unhurried, far beyond our lifetimes. Sometimes I like to imagine what it would look like now. Somewhere, out in the outer darkness where sunlight grows weak and cold, those fragments must still be gliding, silent and invisible. The sun would be no more than a pale star behind them, and ahead would lie the open dark, filled with countless other suns. The particles would move through that dark without sound or resistance, carrying their ancient chemistry onward. They have no destination, only motion, only the continuation of what began long before we ever noticed them. The fading of 3I Atlas is a gentle reminder that observation is itself a form of intimacy. We knew it for a moment, and then it moved beyond our sight. It did not ask to be found, and it will never know that we named it, studied it, and wondered about its origins. Yet, for a short time, our paths crossed. The light that once reflected from its surface entered our telescopes, our instruments, and our eyes. That light now exists in our memory, in our data, and in the quiet knowledge that something from beyond our solar system passed close enough to touch us with its reflection before vanishing forever. The sky is filled with such encounters, brief and silent, each one a reminder of the impermanence that connects all things. 3I Atlas may be gone, but its journey continues, unseen and eternal, a fading whisper in the language of light. No one knows for certain where 3I Atlas began its journey. The sky is vast, and the distances between stars are so great that tracing a single traveler back to its birthplace is almost impossible. When astronomers calculated its trajectory, they found that it did not point to any known system. The direction from which it arrived was filled with stars and faint clouds of gas. Too many possibilities to name. Somewhere, perhaps billions of years ago, in one of those distant regions. It was formed in the cold outskirts of a young solar system. It would have circled its parent star for a time, quietly orbiting, just another small body among many. Then something changed. In the early days of a solar system's life, chaos reigns. Young planets shift positions, giant ones move inward or outward, and their immense gravity can fling smaller objects away. One of those gravitational encounters may have sent 3I Atlas flying. It was cast out from its home, accelerated to a speed so high that it could never return. From that moment on, it belonged to no star. The warmth that had once reached its icy surface grew fainter and fainter until it was gone altogether. The comet entered the interstellar dark, where there is no day or night, only silence and distance. For ages beyond counting, it wandered. The gravity of passing stars would have bent its path slightly, each encounter changing its direction by the smallest degree. Over time, those deflections added up, carrying it across the galaxy. Its surface would have been untouched for millions of years, its chemistry preserved in a kind of deep freeze. It may have passed through clouds of interstellar dust, collecting faint traces of other systems, adding them to its own history. It might have crossed the edges of supernova remnants, where the shock waves of ancient explosions rolled through space like invisible tides. Through all of that, it remained intact, gliding quietly through a universe that had long forgotten where it began. When it finally approached our solar system, it was like a message arriving without a sender. The direction of its path was random, and yet it intersected perfectly with ours. That coincidence alone is astonishing. The galaxy contains billions of stars, each with their own orbits and debris. And yet, for a brief time, this small, forgotten object passed through our light. It is humbling to think that the faint smudge we saw through telescopes was a relic of an entirely different world, a piece of matter that had witnessed the life of another Sunday. The truth is, we will likely never know which star sent it here. Its trajectory has been altered by so many encounters that tracing it backward is like following ripples across a vast ocean. Somewhere out there, its parent star may still be shining, oblivious to the fact that one of its ancient children once visited another system. Or perhaps that star has long since died, collapsing into a white dwarf, leaving behind only memory and dust. Either way, the comet carried the essence of that world with it, the same atoms, the same frozen water and carbon, the same dust that built its home. There is something beautiful about the idea that our solar system and that distant one are now linked, if only through this single traveler. For a brief moment, material from one corner of the galaxy mingled with material from another. Light from our sun illuminated the dust of another star. In that instant, the galaxy became smaller, and the distances between worlds felt less vast. 3I Atlas reminds us that nothing in the universe is truly isolated. Every system sheds its fragments. Every star releases pieces of itself to wander. Over the lifetime of the galaxy, these exchanges must happen countless times, weaving an invisible web of connection between the stars. Perhaps, one day, material from our own sun will drift into the skies of another world, where someone might look up and wonder about its origin, just as we wondered about 3I Atlas. In that sense, the comet's true home is not one single star, but the galaxy itself. It belongs to the quiet movement between systems, to the spaces where light from one world meets the dust of another. It is part of the great, patient circulation of matter that keeps the cosmos alive, and though we may never find its birthplace, we know its story, the story of a wanderer cast out from its sun, carrying a fragment of that lost world into the light of ours before continuing onward into the dark. Every time an object like 3I Atlas passes through our solar system, it brings with it a kind of quiet lesson. We are used to thinking of the sun and its planets as a self-contained family, circling endlessly in familiar paths. The planets move as they have for billions of years, and everything seems orderly and predictable. But then, every so often, a visitor arrives from somewhere else, reminding us that we live in a universe that is anything but closed. The sky, for all its stability, is a place of endless motion and exchange. Interstellar objects like 3I Atlas are not common, but they are not miracles either. They are the natural byproducts of creation. Every solar system is messy when it is young. Planets form, collide, and rearrange themselves in slow chaos, and in that turbulence, countless smaller bodies are flung into the dark. Over time, these fragments fill the galaxy, drifting between stars like pollen on a cosmic wind. Most of them will never encounter another system. They will wander for eternity, unseen and silent. But every so often, one will pass near a star and fall gently into its gravity for a brief encounter. When that happens, we are given a glimpse of something beyond ourselves. When 3I Atlas entered our skies, it became one of those rare glimpses. It was not just a comet but a messenger, carrying with it the chemical fingerprints of another world. Its gases and dust held ratios of elements that reflected the conditions of its birth. By studying its light, scientists could compare it to our own comets, searching for patterns and differences. In doing so, they could learn not only about 3I Atlas itself, but about the diversity of other solar systems scattered throughout the Milky Way. Each interstellar object adds another brushstroke to the portrait of how worlds are made. It is humbling to realize that our understanding of the universe deepens not through grand events, but through small, quiet ones like this. 3I Atlas did not dazzle the sky or bring new discoveries that shook science to its core. It drifted softly through our view, disintegrating before most people even knew it was there. And yet, in its fading, it reminded us that the galaxy is a connected whole. There are no true borders in space, only temporary distances. The same elements that make up the dust of a faraway comet are the ones that shape our own oceans and clouds. When astronomers look at data from 3I Atlas, they see evidence of a larger truth that the matter of the universe moves freely. Stars are not islands but sources, each one shedding material that will someday join another system. In this way, everything is recycled. The dust of one world becomes the foundation of another. The water that once froze inside 3I Atlas may one day melt on the surface of a new planet circling another Sunday. Even in its brief destruction, it contributed to the long, patient evolution of the cosmos. Perhaps that is why these visitors feel so precious. They remind us that we are part of something immense, something that shares its materials across unimaginable distances. To study them is to feel the faint pulse of the galaxy's heartbeat, the slow rhythm of matter flowing from star to star. It makes our solar system feel less lonely. We are not isolated, but part of a vast web of exchange, connected to other worlds by the dust that drifts between them. Long after 3I Atlas faded, that reminder remains. It is still out there, its fragments moving through the darkness, mingling with other particles from other stars. It may never be seen again, but it has already fulfilled its quiet purpose. It has shown us that we are part of an open system, a community of stars and worlds sharing their substance through time. To know that, to truly feel it, is to find a kind of peace in the knowledge that even the smallest things in the universe, dust, gas, and ice, are part of an unending story that connects us all. When 3I Atlas began to disintegrate, there was disappointment among astronomers who had hoped to study it longer. But there was also a softer, more reflective feeling that replaced it. The comet's breakup, while a loss for science, became a lesson in fragility. It was a gentle reminder that even the oldest travelers in the cosmos are not unbreakable. For millions of years, 3I Atlas had endured the silence of interstellar space, surviving collisions, radiation, and endless cold, only to come undone in the sunlight of another star. There was something tender in that ending, something that spoke quietly about the nature of existence itself. Its disintegration was not a failure of endurance. It was the natural conclusion of its journey, the inevitable result of what it was made from. Comets are not solid rocks, but delicate structures, a mixture of ice, dust, and porous material held together by the gentlest of forces. They survive because of cold and crumble because of warmth. When the heat of the sun reached into its frozen layers, it simply became too much. The gases trapped inside expanded, and the surface began to crack. From that moment on, the comet could only unravel. Yet, in that process of coming apart, it shared with us a glimpse of what it truly was. Its weakness became a revelation. There is a certain grace in how the universe expresses its truths through impermanence. Everything that exists does so on borrowed time. Stars burn until they exhaust their fuel. Planets erode and drift, and even galaxies collide and merge, losing their shapes in the process. 3I Atlas was no different. Its brief visit was its one chance to shine, not in defiance of its fragility, but because of it. Without that fragility, it would have remained frozen and unseen, just another silent fragment in the dark. Its destruction allowed it to be visible, to reflect sunlight, to reveal the chemistry of another world. For a few weeks, its undoing made it beautiful. Scientists studying its fragments found that its composition was much like the comets of our own solar system. That realization was profound. It meant that even across light years, even between different stars, the universe builds in familiar ways. The same icy materials that made up 3I Atlas are the ones that fill our comets and asteroids. The same delicate bonds that caused it to crumble are present in the bodies that orbit our own Sunday. Fragility is universal, and in that there is connection. For those watching from Earth, the comet's soft collapse might have looked like an ending, but endings in space are rarely final. The pieces that broke away continued their journey, each fragment reflecting sunlight for a while before fading. Over time, they dispersed into the solar wind, becoming part of the invisible dust that flows through our system. Some of that dust may one day collide with other particles, sticking together, beginning again as something new. The story that began in another star system did not end here. It simply changed form. It is tempting to mourn the loss of something so ancient and distant, but perhaps it is better to think of it as a kind of release. For so long, 3i Atlas had been held together by cold, its potential locked inside ice. The warmth of the sun freed it, not only from its structure but from the boundaries of its own history. It became part of something larger, part of the continuous exchange of matter that fills the universe. Its fragility was not weakness but participation. In its quiet unraveling, 3i Atlas offered a reflection of our own condition. We, too, are made of impermanent things. We live, we change, and we fade, and in doing so, we contribute to the ongoing story of everything. The comet's short life near the sun showed us that transience does not lessen meaning. Sometimes it deepens it. Its beauty was in its brevity, in its surrender to forces beyond its control, and in the reminder that all things, even those that last for millions of years, eventually return to light and dust. There is something quietly comforting about the idea that our skies are still open to visitors. The universe, for all its unimaginable size, still sends small wanderers like 3i Atlas across the distances, passing close enough for us to notice. We often think of our solar system as a closed bubble, its planets and comets belonging only to the Sunday. Yet now and then, something drifts in from beyond, carrying with it a trace of the wider galaxy. It reminds us that our night sky is not just a dome of stars but a meeting place of countless paths. When 3i Atlas arrived, it did not announce itself with brilliance. It moved softly, quietly, as if it did not want to disturb the stillness of space. The telescopes that caught its light captured something faint but extraordinary, a messenger from another system gliding through ours. For those who watched it, even from afar, there was a certain feeling that cannot be put into equations or data. It was wonder, but a sleepy kind of wonder, the kind that makes you look up at the stars and imagine the endlessness beyond them. At night, when the world is quiet and the air still, it is easy to picture 3i Atlas drifting somewhere beyond our sight, continuing its long journey through the dark. It may have broken apart, but its dust still travels, each particle reflecting a sliver of sunlight as it goes. Those fragments might someday reach another star, another world, and perhaps someone there will see them and wonder about us, the same way we wondered about them. The idea that these tiny travelers could connect different corners of the galaxy is strangely soothing. It means that the universe, though vast and silent, still allows for moments of communion between distant places. For many, comets have always carried an air of mystery. Long ago, they were seen as omens, bright strangers whose appearance marked change. Now we know they are made of ice and dust, yet they still feel like symbols of something more. When we look at them, we are not just seeing frozen material. We are seeing stories of formation, survival, and impermanence. 3i Atlas was one of those stories, though we caught only the final chapter. It had spent perhaps billions of years traveling from its birthplace, crossing the void, untouched by starlight, until finally arriving here, where it glowed for a short while before dissolving. Its life was long, but its moment of visibility was brief, like a sigh after an endless silence. There is comfort in knowing that such wanderers exist. It makes the universe feel alive, in motion, full of quiet exchanges. Somewhere, right now, another fragment from a distant star system may be on its way toward us, invisible for now, but certain to arrive someday. And when it does, someone will be watching, perhaps on another still night, tracing a faint glow in the darkness and realizing that they are witnessing the passing of another ancient traveler. To think of 3i Atlas this way is to think of connection. Though we may never see it again, its passage through our solar system linked us to another place in the galaxy. It left no mark that we can touch, but it left an impression on our imagination. Even as we sleep, even as we dream, we are part of a universe filled with such meetings, moments where distant histories cross paths and continue on their way. So perhaps, as you lie under the quiet of the night sky, you might imagine it still out there, gliding through the blackness, carrying fragments of a world we will never know. You might picture its dust glowing faintly, turning slowly in the starlight, unbothered by time. And as you drift toward sleep, you can hold on to the thought that every bit of light above you has its own story, and that sometimes those stories visit us for a moment before continuing their eternal journey through the dark. In the years after 3i Atlas faded from view, astronomers began to think about what might come next. The discovery of interstellar visitors like it has changed the way we see our place in the cosmos. For most of human history, we believed that what circled our sun was unique, that our comets and asteroids belonged only to us. But now we know the truth is wider, more fluid. The space between stars is not empty. It is a slow, quiet highway for travelers. Somewhere out there, more are already on their way. Future wanderers will come, just as 3i Atlas and its predecessors once did. Some will arrive as fragments of other worlds, pieces of stone and ice carrying the chemistry of distant suns. Others may be older still, their surfaces darkened by radiation and time, their structure changed by countless collisions with dust and cosmic rays. They will appear suddenly, as faint points of motion against the stars, and for a few brief months or years, we will have the chance to study them before they, too, continue on their endless routes. The galaxy has no shortage of such messengers. We have only just learned how to notice them. Each new arrival will tell a different story. From Oumuamua, we learned that interstellar objects can be strange, shaped in ways that defy easy explanation. From Borisov, we saw the beauty of a true interstellar comet, active and alive with vapor. From 3i Atlas, we learned about fragility, about how easily something ancient and cold can fall apart when touched by sunlight. The next visitor might bring another kind of revelation, something we have not yet imagined. Perhaps it will be rich with unusual metals, or perhaps it will move in a way that challenges our understanding of gravity and light. Every time one appears, we are reminded that the galaxy is still speaking to us, quietly but clearly, in the language of motion. To study these wanderers is to participate in a kind of cosmic archaeology. Each one carries within it the record of its home system, frozen in its materials. They are fossils of creation, preserved in deep cold. By examining them, we can glimpse the conditions that shaped worlds beyond our own. The ratios of gases, the composition of their dust, the isotopes in their ice, all of it helps us piece together how stars and planets form, not just here, but everywhere. In that way, every interstellar visitor is a teacher, offering a small lesson about the wider universe. It is likely that many more of them have passed through our solar system without being seen. They move silently, faintly, often smaller than we can detect, gliding through the black without light to reveal them. But our instruments are growing sharper, our eyes more sensitive. One day, perhaps soon, we may find another before it has even arrived, tracking its long approach from the depths of space. When that happens, we will have the chance to greet it properly, to prepare our observations, to listen more closely to what it has to say. When you think of it, the passage of these travelers is not random. It is part of the natural rhythm of the galaxy. Every system casts its fragments into the dark, and those fragments move between the stars, connecting everything in an invisible web. They are the galaxy's way of mixing itself, of ensuring that no place is truly isolated. Even now, somewhere in the darkness, a new visitor may already be falling toward us, drawn by the same quiet pull that once guided 3i Atlas. The future wanderers will come as 3i Atlas did, softly, with no warning, appearing one night as a faint glimmer and vanishing soon after. They will remind us, again and again, that nothing drifts alone. The universe is alive with motion, and within that motion lies a kind of continuity, a shared heartbeat among the stars. And when we see them, when we follow their fading trails through the sky, we will know that we are witnessing not the exception, but the rule, that this quiet exchange between worlds is what the cosmos has always done and will continue to do long after we are gone. Even though 3i Atlas is gone from sight, its journey has not ended. Somewhere in the vast dark between the stars, the remnants of that fragile traveler still move, invisible but not lost. The light that once reflected off its icy surface has been captured in our records, stored in data and memory, a faint echo of its presence that endures long after its body has dispersed. The story of 3i Atlas now exists in both the sky and in us, preserved in our curiosity, our measurements, and our quiet awe. When astronomers trace its orbit on a screen, they see a thin curve winding through the solar system and then stretching outward into infinity. That line is more than just a mathematical path. It is the ghost of motion, a record of the comet's passage through our light before it continued on its way. The data points that mark its location, numbers written in neat columns, hold a strange kind of poetry. They are coordinates of absence, the last footprints of something that can no longer be seen. Each observation, each pixel of brightness, was a moment when sunlight touched it and bounced back to us, carrying information across millions of kilometers. In those reflections, the comet spoke, however briefly, in the only language the universe truly knows, the language of light. Now, that light is part of our collective memory. It lives in photographs, in computer models, in quiet notes written by scientists who stayed up late to watch it fade. In a way, 3i Atlas has joined the long tradition of things that no longer exist but continue to matter. Its physical form may have crumbled, but its presence remains through the understanding it gave us, the sense of connection it inspired. The data we keep is not just information, it is remembrance. There is a certain peace in thinking about it this way. The comet's dust may now be scattered, but it is not gone. Each grain still drifts somewhere out there, illuminated now and then by the distant light of stars. Those tiny particles are part of the same cycle that builds and rebuilds the galaxy, moving from one place to another, becoming part of new formations, new systems. Over time, they will mix with the interstellar medium, that invisible ocean of dust and gas that stretches between stars. In another age, they may even become part of a planet, or a moon, or another comet, beginning the cycle all over again. For us, though, what remains is quieter, but just as meaningful. The records of 3I Atlas rest in digital archives, in observatory logs, in the soft hum of servers holding the memory of its passing. Every once in a while, a researcher will revisit that data, plotting its orbit again, comparing it to newer discoveries. When they do, they are, in a sense, waking it briefly, letting it drift through human thought once more before allowing it to settle back into silence. The comet becomes alive again for a moment, not in space, but in the mind. It is a comforting thought that even something so small and transient can leave a lasting mark simply by being noticed. 3I Atlas did not need to last forever to matter. It only needed to exist long enough for us to see it, to wonder about it, to write its story into the great record of the cosmos. Somewhere, beyond the reach of telescopes, its fragments still travel, guided by the same laws that govern stars and galaxies. They are part of the same grand motion, the endless rhythm of creation and dissolution that defines the universe. So when we think of 3I Atlas now, we do not think of its end but of its continuation. Its light still moves, faint but unbroken, across the darkness. Its orbit remains drawn upon the map of the sky, and in the silence of that infinite space, where everything eventually becomes part of everything else, the memory of its motion hums quietly. A soft echo of a traveler who came, shimmered for a moment, and then gently disappeared into forever. So, as you drift off tonight, remember that even the quietest visitors in space leave echoes behind. 3I Atlas may be gone, but its dust still glimmers in sunlight somewhere far beyond our sight. Every tiny fragment is a story, and every story is a lullaby written in the language of starlight. Sleep well, dear dreamer, and may your dreams be full of distant comets, ancient ice, and the gentle hum of the cosmos itself. And if your thoughts are still awake, perhaps let them wander softly into the comments and tell me what part of the universe would you like to visit next in your dreams.